Hello and welcome to episode 2 of my How to Do Redstone tutorial series. In this episode we will be looking at different circuits, so a combination of different components that you will find all over builds and are pretty much usable in most areas of Redstone. So it's recommended that when you're learning Redstone you know how components work together to make a certain structure, or circuit in this case. We're starting off with redstone clocks. So redstone clocks are when a redstone pulse is flashing on and off, so it can be used to repeatedly turn on and off things. Here we have a simple torch clock where this torch is turning off this one, which means this one is on, however it's turning off this, which creates a loop, and this is why the redstone flashes. This can also be done with repeaters when you put a short pulse into it. The issue with it is if you power it permanently like this, it's permanently stuck in that position and you cannot turn it on or off because the repeaters infinitely power themselves. Here's also a slower version of it. So what you can do is you can combine a torch and repeater like this, making this clock but practically with a torch instead here, and this you can now toggle on and off. Another very common clock is a double observer clock, where the observer is observing this observer, who observes the observer observing the observer, which then causes the trapdoor to infinitely flash. You can turn it off by just moving the observer out of the way with a sticky piston. So yeah, clocks that can be turned off are always very useful. Here we have a redstone torch burnout clock, and it works basically when you have a redstone torch on a block. It's powering the block above it, and this is then powering the dust, which is powering the torch. This causes it to flash briefly and then turn off. So it flashes 8 times and then turns off, it like burns out. And what you can do is you can update the redstone dust and then it flashes again. It's a lot faster than the observer clock here, as you can see. So if you don't want to have constantly a button press, what you can do is you can put 2 of these next to each other and start the clock, and it infinitely goes, with always the left one here, in this case burning out because that's where we place the block last. What you can also do is have a torch here, a repeater here, and the block here, which is very similar to this thing, except it's one slice, and it also infinitely flashes. Here we have, this is another clock where we have the piston powering the torch, which powers the piston, it's also loop. And here we have this clock. What you can do here is if I quickly break this and place this again, it creates a clock piston. However, that one is really difficult to reset and turn off like the first one, which is why you can do it like this. Here we have an item in the hopper, and when we unlock this hopper by unpowering it, it can cycle left and right, which allows us to always detect when the hopper is this. This clock is rather slow, as it depends on hopper speed. But what you can do then is, all of these clocks, they flash rather quickly and consistently. What you can do is, we have an etho hopper clock here, and what happens is we can put any amount of items in here and it will cycle all the way, fill up, and then cycle all the way back. We can have a really slow clock. It's a sort of sand timer basically, and it will always move the position whenever the blocks have completely moved over. With comparators powering the pistons here, and turn it off, we just power one of these, and the output can always be taken wherever the redstone block is. Here we have another clock. It's just a redstone block being pushed around and then powering the pistons themselves. And here's the same thing, but instead of a redstone block with torches powering the blocks, and then it goes there. So that's redstone clocks, and yeah, there's a ton of different redstone clocks. These are not all. There'll be variations of all of these, and there'll be definitely more out there. However, these are the more common designs. So next up we have a section about redstone pulses. redstone pulses are useful because sometimes we don't want a component to be powered permanently and we just want it to briefly flash in a circuit. A redstone pulse can be generated in multiple ways. The first way is a button, for example, that generates a 10 tick pulse with a stone button, a 15 tick redstone tick pulse with a wooden one. Updating observer creates a brief pulse of 1 tick long. Here we have a pulse generator that we can vary. Here it's a 1 tick pulse. Here we have a 2 tick pulse, 3 tick pulse, and a 4 tick pulse. Of course you can add more repeaters here. And like this we can generate a really long pulse. Okay, now this wasn't long enough. Of course, if you want to have a pulse generator, the input pulse needs to be long. So a pulse generator can turn any long input into a short one. So any infinite one into a short one. Here we also have a monostable circuit, which basically shortens a pulse, which also acts as a pulse generator if you put anything in there. So here we have an infinite pulse coming in and a 1 tick pulse coming out. And here's a similar thing, but this time it's a 4 tick pulse, and that's a 1 tick pulse. So another way to show how a pulse can be shortened, here we have a 4 tick pulse generator, it's that one, and here we have a 1 tick pulse generator, and here this will be infinite. I'm using trapdoors here because redstone lamps have a delay when turning off, so it's not very good to show pulses. And as we can see, this one was briefly on, or this one was a bit longer, and this one stayed on. Next up, from pulse generators and pulse shorteners or monostable circuits, we have pulse extenders. This is a very common pulse extender here, where we have comparators going this way, then it crosses once over, and then goes back the other way, and we have a block here. The reason we have a block here is because if we have a dust here, it will be half the duration. I can show it like this. And basically what's happening here is this trapdoor stays on. As the comparator, initially a 15 goes in, the 15 goes across of the signal strength, then it goes over here and becomes 14, crosses once again, is 14 here, goes through, becomes 13 over here, and it loops. And that depends on the speed of comparators. You can add more layers of comparators to extend it. However, you have to be careful that the pulse going in has to be able to encompass all comparators. So for these 6 comparators here, we need an at least 6 tick pulse to go in. If we remove the block here, you can see it can decay 1 here and decay once there. So it will decrease a lot faster. And next, the disadvantage with this one is eventually you'll have to have a super long row of comparators for very long pulses, which is why we have this thing here. This pulse generator has a hopper facing into a dropper here, comparator repeater this way and comparator repeater this way, and then a block with a redstone torch and 2 hoppers. You have 16 items in one of these, which means the pulse will have the duration of all 16 items going this way and back again. And to start it, there's just 1 item in here. You can click it and it turns on, and as you can see, the items are filling up, and then they will go down again, and yeah, it turns off. So here we can create really long pulses with a total of 320 items being able to fit in here. So next off we have pulse multipliers. It turns a single pulse into multiple pulses. Here we have an observer, which flashes twice after only 1 pulse going in here. Here we have a comparator on subtraction mode. It loops into itself. So there's 15 going here, then a 13 here, which subtracts it and actually becomes 2 here. Yet still flashes. What's important to remember here is this dust here is not flashing between 15 and 0, but it's actually flashing between 15 and 2. So if we have the trapdoor one block closer, it will stay on permanently, as you can see there. That's why I have it a distance of 2 away, because this will become 2, this will have a signal strength of 1, and this will be 0, which is why this flashes. The reason you can also put a target block here is because when this is in the state of being a 2, not a 15, this is 1, this is 0, and therefore the trapdoor can flash. But here we have another pulse multiplier. Here again we have items that get dispensed into this hopper, and then for the duration that there's items in this hopper, it will flash. And again, to turn on, we have a dropper dropping an item into this hopper. It looks like this. So to show you guys, I can power it. I'm gonna see it flashes while there's items in here. It counts up, and then starts counting down. But however, different to the pulse extender, it only flashes while items are being dispensed into that direction, so not on its way back. And finally, we have some pulse dividers. It takes multiple pulses and turns it into a single pulse. In this case, we have 3 of 2, 1, so I can press this button once, twice, and thrice, and there you can see the trapdoor flashed. And it looks like this. There's a torch there, and these hoppers loop into this. And here we have again a pulse divider where you can set it to have a lot of inputs. Here we have a single item in here, and we have 5 items in there, so it converts 5 to 1. It looks like this. And as you can see, I can press it once, twice, thrice, 4 times, and the 5th time, and that flashed. And the flash has the duration of the items in here needing to return. So yeah, it has a cooldown basically. So if you have so you need to consider you can't fill this dropper because it will never fill up the hopper. So you can have a total of 5 stacks in here, which is again 320 items. But if you do that, you will have to wait very, very long for the cooldown to reset. So if you have a very long pulse divider with the long pulse coming out, you should probably make 2. Well, while one's on cooldown, the other can be in use. And another pulse generator I missed actually is here. When we take this ether hopper clock, the block that the comparator is connected to is actually a pulse generator that is timed. So as you see, it just flashed there once, and then we wait again, and every time the redstone block comes back, this torch flashes. So that's also a neat pulse generator. So yeah, that's everything on pulses. The next section we have is some useful things that you will see in a lot of builds are useful and are not in those categories. And of course, these are not the only designs out there. There's hundreds of designs. So here we have a T flip-flop. You turn on, it stays powered. You can take a pulse and make an infinite signal. And here you can flash it again and it turns off. I believe in logical redstone they actually have a T flip-flop is a bit different, where it has a clock running. I may be wrong on that, but I'm pretty confident. Yeah, but a T flip-flop in all other redstone is usually when you have a block, you can power it, turns on, and it stays on. And there we've got the recent addition of the copper bulb. T flip-flop from before was this. You have a dropper facing into. Sometimes there's a dropper here, but then they were taking readings a bit difficult, so the dropper dispenses the block, it shoots it at this block, it falls into this hopper, and it goes in here. And then the next time you press it, it goes up, or at least in this case it's down there now, the block, as you can see. Or if we flash it again, it's up here and we can take a reading. So this is how, this is a common T flip-flop before the copper bulb was added. Next, another useful redstone or machine circuit is a randomizer. Here we basically have 9 items in here. A sword, which is only stackable in one. You can't put two netherite swords on the same block, while these are all stackable to 64. For that reason, the comparator will detect a different signal. When there's something stackable to 64 in the hopper, it will power only one lamp on, while if it's a sword, it will power 3, as I can show you here. Firstly, to activate it, we need turn off this lever, so that's to turn it on. And now you'll see this torch is on, and there is a redstone repeater in there. So it's a 1 in 9 basically to get the sword, so we may have to wait a while. So now it's the repeater still. That's the redstone dust. Now it's the dropper. So as you can see, you can make casino games or something with this, or any randomized base system. And yeah, unfortunately, due to the odds being not in our favor, it may take a while to get the netherite sword. It may remove about 3 items, so now there'll be 1, 2 for the redstone dust, 2 for 1 lamp, and yes, now we can get the sword, because the probability has significantly increased. Sword twice, sword 3 times, a single lamp. Yeah, so that of course made the probability higher. But yes, if we put the items back in again, the probability to get the sword decreases again. Or we actually got it that time. So yes, that's a common randomizer, and to turn it off you just power this block. The next randomizer we have is actually a chicken based randomizer. There's an egg in there. Creative mode, so yes. Basically it relies on the fact that mobs have random AI, and you can just take an output to wherever pressure plate they're on. You can also take an output to the pressure plate in the middle. With the chicken, it likes to stand on the middle of 2 blocks for some reason a lot, and therefore the middle will nearly always be on. An issue with this one is the chicken may lay an egg and will therefore the egg will be on the pressure plate, so I recommend using stone pressure plates instead of wooden ones, because that cannot detect an egg. Another randomizer is a cactus growing base randomizer. When the cactus will grow, it will activate this observer, which then can take an output from. I just replaced the block back on here, it's a normal piston. So we'll continue moving on and come back at the end of the video and see if this block has been pushed up when the cactus randomly grows. Next we have a piston extender. It's a double piston extender here. Basically, you can move a block 2 this way and then bring it back again. Except it doesn't, because this is on the wrong delay. Okay, yeah, you can push it and bring it back again. And this is how you can make a horizontal one, and this is a vertical one I came up with. Yeah, here the observer is looking at this repeater on 3 ticks. And here we're 4 and 2 ticks, and here 3, this makes 3, this makes 6. And here we have a triple piston extender. This is this side and this is this side. I did not build a vertical one for that. Another group of redstone we have is slime block and piston and observer base redstone. Here we have a simple flying machine. Yeah, you can turn on by activating this observer. It's just gonna do its thing and leave now. So next we have multiplexers. So multiplexers, basically if you have 2 inputs, you can power a single output and choose which one to use. Currently this selection lamp is off, so when I can toggle this one, and that directly affects the output. However, if I change this one, it does nothing. However, if I change the selector mode, this one now does nothing, and this one goes to the output. It looks like this. And here's a small design I made. I think this can be even made smaller. By putting the repeater here. This off. Lamp. That sign. Wonderful. Okay, well now that powers both of that. Yes, this is the selection mode. Or it's not. Good. So, this is the first input. This is the second input there. And this is selection. And this needs to be on a block because there's a torch here. So basically if that's output, you can turn this on and directly affects the output. And also take an output over here, basically any block here. This is basically the output here. I came up with this design too. So yeah, we can power it on and there'll be an output. We can try powering with this one, does nothing. And just return the lamp here. But this does nothing, this affects the output. And when we change the selection, this now can affect it. And this cannot. And I'm quite proud of this design because it's very interesting how it works. So yeah, that's how it works. Yeah, nice. Next we have relays, which is a multiplexer, but opposite. It takes one input and you can spread it to two outputs. Here, we're currently making it go to the second one, and when we toggle this, it goes to the left one. And yes, these are often used in logical redstone. Next, I'll go through quite a lot of logical redstone things. However, although not everyone intends to use redstone to build computers, there's always a use in it in most redstones, for example AND gates over there. So in logical redstone, this is just wire, it's redstone. The NOT gate would be a redstone torch. Here we have an OR gate, which is just redstone coming together. Here we have a NOR gate with just redstone coming together and a torch on the other side. And of course the OR gate behaves like normal. Here we have an AND gate, which is two torches, dust, and then the dust powering a third torch. A is on, nothing happens. B is on, but when A and B are on, it turns on. And here with the NAND gate, we just removed the torch from here. But this doesn't do anything, this doesn't do anything, but when both of them are on, this turns off. And finally, we have an XOR gate here. Left can turn on, it turns on. Right can turn on, it turns on. However, when both of them are on, this is off. I used this in my episode where I showed how to wire a door correctly. I recommend you check that out too, because it's quite interesting. And then for the XOR gate, you can put a torch there. So yeah, that's the XOR gate. Or what you can do is you can put a torch on one of the inputs. And that works correctly. This of course has not been compacted at all. These are all just for show and can be made a lot smaller. And finally, that was it. Okay, well, I hope you enjoyed that. If you are starting redstone, it's useful to know about one of each type. So it's useful to know a clock that you will use. It's useful to know quite a few of the logic gates. You should know like the ether hopper clock, and although you might not memorize them initially, you will find them in a ton of redstone builds. They always are found, and yeah, it's good to know them because they're very useful, and that's redstone circuits for you. In the next episode, I will show me using some of these circuits in some builds, and unfortunately our characters have not grown yet. But as you saw, I had to place the block back there, so it had grown at some point while recording this. But yeah, it's really useful to know these. You'll find them in all the redstone builds, and in the next episode I will be making some builds and using these. And I'll also give some tips how to effectively get into redstone and start making a build for yourselves. But until then, consider subscribing so that you don't miss that episode, and maybe even check out the first one if you haven't already. Thank you very much. Hello again. I just cleaned up the multiplexer because I didn't like how it looked during the tutorial or demonstration. So there's A, there's B, there's select, and there's output, and this is how it looks like from above. Thank you very much. Hope you enjoyed. Have a great day.